Question 5. This is the calculus question. Given that the function f of x is equal to brackets x minus 2 times brackets x squared minus 5x plus 6, you need to find the first derivative. Now you can't find it just yet unless you expand the brackets above. You do need to have some sort of algebra skills in order to expand this correctly. Write it out again. I forgot to remind you guys, some of you written your response on the question paper. For paper 2, you must always write on line paper. Start each question on a new page, not a new sheet of paper, on a new page. Okay? And label all the parts clearly. Right. Here, what you can do is you times the x into all three of these terms and times the negative 2 into all three of these terms. So the first one, x times x squared would be x cubed, and then negative 5x squared, and then 6x. Negative 2x squared, this is negative 2 times negative 5x, which is positive 10x, so plus 10x. Last one, negative 2 times 6, take away 12. Now group the like terms together. You have the x squared terms. You also have the x terms. X cubed minus 7x squared plus 16x minus 12. So when you go up to here, you got 1 point. Expand and simplify. When you do the correct differentiation, all the terms correct, then you will get the rest of the 2. So term by term, this becomes differentiate to 3x squared minus 14x plus 16. So this is the first derivative. B, you have a point A with coordinates 1, negative 2, and it lies on the function. Find the gradient of f at the point. Well, we know that at A, the x coordinate is 1. So we can put that into the first derivative, because your first derivative is your gradient function. It tells you when you put the x coordinates in, it tells you at that particular point what the gradient is, the gradient function. So you have 3 times 1 squared minus 14 times 1 plus 16. You have 3 minus 14 plus 16, which is equal to 5. So the gradient at point A is 5. What part is this? Oh, it's just B. Moving on to part C. Give your answer in the form ax plus bx plus c equals to 0, where a, b, c are integers. Whole numbers, positive, negative whole numbers. And you must give it in this form. Now the gradient of the tangent at the point. So if you have some sort of function and then you have a point A there, the tangent is the one that just touching that point. That's the tangent. So it has a gradient of 5, passing through the point 1, negative 2. This is part 1. So part 1, we have y minus, let's use the point gradient formula. So it is y minus y1 equal to m times x minus x1. So that's the general formula. We do y minus negative 2 equals to the gradient times x minus 1. So y plus 2 is 5x minus 5. We want it in this fashion. So we want ax plus bx plus c. I'm going to rearrange everything from the left-hand side to the right. So 5x, take y away, take 5 and take 2 away. So becomes, take away 7. So this is the equation of the tangent. Equation of the normal. The normal at point A is the one that goes cross it at 90 degrees. So it has to be perpendicular to the tangent. They're passing through the same point, but what happens to the gradient? The gradient must be the negative reciprocal. So the gradient for this orange line has to be negative 1 over 5. That takes us to the next part. Repeat the same thing. Y minus negative 2 is equal to negative 1 over 5 x bracket x minus 1. So y plus 2. Actually, I'm going to times it by 5 on each side as well. So I have negative x, take away 1, or negative 1. So 5y plus 10 is equal to negative x plus 1. Rearrange everything. We will have negative x, take away 5y, take away 9. Okay, let's do some checking. So y plus 2 times this. So 5y plus 10. Take 5y away, take 10 away. Yep, so that would be the equation of the normal. So that's part ABC. Part D and E. Part D says find the coordinates of the stationary points and state the nature of each point. That's telling you to say whether it is a min or a max. You need to justify your answer. The best way to justify it would actually be drawing a sketch in this case. So let's move over to the GDC. I need a graph. I actually still need the functions. I need to draw it again. You need to draw the original one, isn't it? So let's do bracket x minus 2, bracket x squared minus 5x. This is what the graph looks like. Now I can barely see that it goes up and down, crossing the x-axis. In order to have a better look, I am going to use zoom box. Zoom box allowed me to just focus into a certain region. So that seems good. If I want to have a better look, I can do it like this. Even better. So press escape, you can get out from the zoom function. Now, this is what we need. We need the max, the min. We need to know where they are. I'm going to analyze the minimum. Needed manual analyze graph to get the maximum. Let's draw the sketch. So we have this, we have the 2, we have 3, 2.67 is right there. So because you don't have the y-axis, it would be better that we state the coordinate point. And then we have another 2, 0 here. You got up, and then down. Whew, let me try again. Down, and then probably this. So you find the coordinate points, and then you name it. This is a max, and this is a min. That's how you get your 4 points. Because you were asked to find the coordinates of the stationary point, 2 of them, and from the diagram, clearly this is a max, this is a min. That's part D. Part E, hence, state the values of x in which f of x is decreasing. So when is f of x decreasing? This is when the gradient is 0 here. The gradient is also 0 here. Before this is increasing, this part is also increasing. The range, the domain or the section that where the function is decreasing is here, which is in between 2 and 2.67. And this is your x. To express the answer, you write x is in between 2 and 2.67. Done.